Hello everybody. Today we're going to talk about the graphs of the other four types of trig functions. We have dealt with sine and cosine extensively in class, and this picture that you see right now is one of those graphs. We know about the basic form of sine and cosine. We know how to move them left, right, up, and down. We know how to change the period and the amplitude. And we're going to use that knowledge about sine and cosine to do secant and cosecant first, which are very easy graphs if you can do sine and cosine well. So let's start with a secant. In order to graph secant, I'm going to use this cosine as an example. This cosine graph has been shifted up to get our new sinusoidal axis. It has an amplitude of 3, so you can see from the middle up and the middle down is 3 units. Its period is going to be 360 divided by 2, or 180. So every 180 degrees we complete the full revolution of the graph. And then it's been shifted to the right 45 degrees. So you should recognize all those characteristics. Now let's assume that you are given this question. So let's talk about the relationship between cosecant, or between cosine and secant. You should know that secant is 1 over cosine. So if we have all of these values graphed for cosine, 1 over them should be the value of the secant at that point. Okay, so basically what that means, think about this as ground level. Whenever the cosine is at 0, now I understand that this technically is not 0, but in our new shifted and twisted and stretched system, that is ground level. So this is level 0. Whenever your cosine graph is getting close to that 0, technically what we're doing is sort of 1 over 0. You can't really do 1 over 0, but you're doing things like 1 over 0.0001. And this is kind of, a more advanced idea that you'll deal with a lot in calculus. But when you do 1 over a very, very small number that's getting closer and closer to 0, your overall value is getting closer and closer to infinity. Basically, a whole number over a tiny, tiny fraction approaches infinity. So what that translates into for this graph, whenever your cosine graph is at ground level, that's going to produce an asymptote in your secant graph. Okay, so start by drawing the cosine, or if you're trying to draw a cosecant, you'll start with sine. And wherever your graph touches the sinusoidal axis, just draw a vertical asymptote at that x value. Like that. Do this a little faster. Okay. All right, so again, I realize that that's not technically 0, but that in our new frame of reference is our new ground level, our new 0. Now, all you have to do is wherever your cosine graph was at a peak or a valley, draw a little U-shaped piece of graph that lives between the asymptotes. Now, a lot of people call those parabolas. Those don't technically have the properties of parabolas, so don't say that. Just say those are the secant graph. Everything up until now is all dashed because this is not part of the graph. So if this is a test question, you need to put everything in dashed lines except the actual secant graph. And that actual secant graph is going to look like this. We just do little U-shaped graphs between all of those asymptotes. And that is what a secant graph looks like. So if you can graph cosine, which I know you can because I've seen you do it, you can graph secant. And if you can graph sine, then you can graph cosecant. So we don't need to spend a lot of time breaking down this graph. Just realize that they're inverses of each other as far as 1 over that style of inverse. And that's what happens to your graph. So while a cosine graph only exists between those horizontal, not really asymptotes, those horizontal levels, the secant graph only exists outside of those levels. All right? So I'm not going to even do a cosecant. If you have a cosecant, start with sine and put the little u's on it just like we did here. Instead, let's talk about our other two that haven't been drawn so far. Using this unit circle, let's do a graph of tangent and cotangent, just the regular non-shifted and stretched values. So our unit circle values are the coordinates. The tangent is always the sine over the cosine, correct? So sine is our y value and cosine is our x value. So tangent here is equal to 0 over 1 or 0. And let's only look at the 45s just to simplify this. Tangent at all your 45 places is 1 or negative 1 depending on the quadrant. And then as you approach this way, calculating the tangent every time, you are getting closer and closer to 1 over 0, and that's undefined. All right, so that's doing something similar to what just happened on that secant graph. You're getting closer and closer to 1 over 0, which means that here, tangent is undefined, or in a way, tangent is infinity. Okay, your tangent is going to get really, really, really big the closer you get to the top, the 90-degree point. Then over here, tan is negative 1. And then over here, tan is 0 again. And let's just sort of follow that pattern and create a graph. Tan is undefined at 90, and it's also undefined at 270, and negative 90 and negative 270. So let's throw some asymptotes in. 90 degrees, not allowed. The tangent will not cross this value. You're not allowed to have your graph cross this line. Okay, other places, basically every 180 degrees from there is going to be another asymptote. So that's going to happen at 270, that's going to happen again out there, 180 from there, which would be, what, 450, negative 90. Every 4 spots, we're going to get a vertical asymptote, because that's where we approach the north and south pole on the unit circle. So let's use those values that we just calculated. At 0, we are at 0. At 45 degrees, we're at 1. And then we start going up towards the asymptote. At negative 45, by the way, we would be at negative 1. So, get a little bit lighter pen here. We follow this sort of, call them S-curves. They're not really S's, but that's the graph of a tangent. Right? And it resets itself every time it gets back to one of the poles. So you're just going to recreate that same picture over and over again. Notice that the period of a tangent graph is 180 because it starts a do-over every 180 degrees, not every 360. And that's going to affect the way we twist and turn one of these graphs. So there's your standard tangent graph. And without a whole lot of extra work, I'm looking for my asymptote, draw a new asymptote. Cotangent is going to be pretty similar, although its 180 degree cycle starts at 0 and goes out to 180. Instead of going from minus 90 to 90, it's going to go from 0 to 180. Okay, so every 180 degrees, it's going to have an asymptote, but those asymptotes are on the 180s, not on the 90s. Because if you refer to your unit circle, those are the places where you can't take a cotangent. I can't take a cotangent at 0, because at 0 degrees, cotangent is 1 over 0, which is another way to say infinity. The other difference is cotangent is going to come down from the top. All right, my cotangent value sort of starts at positive infinity and works its way down. It's going to have those 1 and minus 1s on the 45s, but your cotangent graph is going to look like this. And it's going to repeat itself over and over again, just like the tangent did, only reversed. It's offset by 90 degrees, and it is going downward. So there's your basic tangent and cotangent. And one more thing. Let's do one that's been twisted and turned and stretched. All right. This one has a new axis that's up 3. This one has an amplitude, sort of, but I'm going to mark that one out because that really would affect how steep your little curves are, but that doesn't, we're just sketching anyway, so you don't really need to worry about the two. The period, however, when we did the other 4 types of graphs, sine, cosine, secant, cosecant, you take the original period and divide it by that number. With tan and cotan, this is probably the most missed points on this test. Take the original period, which is pi for tan and cotan, and divide it by that number there that's in front, or right after the tangent. So pi divided by 1/2 is 2 pi. And then this one's going to go right, pi over 2. So, your steps in drawing this graph. First of all, you can do your up 3. I'm not worried about the quote-unquote amplitude at 2. That's just going to affect, but since this is a sketch, it doesn't matter. Next, whatever was at x equals 0, I'm going to move that right pi over 2. So I had this point that was on my standard tangent graph, and since it moved up, it would be here. I'm going to start by moving that right pi over 2. My new starting point is here. All right, there can be some trickiness there. Whatever was at your y-axis, move that, whether that's an asymptote like in cotangent or whether that's a point in tangent. Start there. Now, with pi over 2 as my starting point, I need to have a period of 2 pi. So I'm going to go pi in either direction. I'm going to go out here to 3 pi over 2, and I'm going to go down here to negative pi over 2. Starting at pi over 2, I went pi in both directions to get the little home where this tangent graph will live. And then for me, every 4 is still going to be where each one lives. All right, each one will go through this middle point, and it's a positive tangent graph, so it's going to go up like this. You don't have to get real fancy with your tan and cotan graphs. Just get your framework set up with all your asymptotes, and then put in the quote S curves going in the right direction. If this had been negative tangent, by the way, a negative tangent looks like a cotangent in that the graphs go that way. This is positive, so it's going to be like that. So just remember, whatever was on the origin, if it's cotangent, you're going to have this asymptote on the origin. You would take that and shift it over to pi over 2. With tangent, I'm going to take that kind of base middle point that was in the very center of my original graph, and I'm going to move it over to pi over 2. All right, so there is tan and cotan graphs. Remember, secant and cosecant graphs, piece of cake. Just draw sine or cosine, put the little u's on top. Tan and cotan, a lot of similarities, except you don't really have to worry about the amplitude, and the original period was pi, so make sure that when you find the new period, you use pi to calculate. And when all else fails, plug in a couple points and make sure you're in the right place. Make sure your asymptotes and your points are in the right place. All right, so that is it for our other 4 graphs. Hope you've enjoyed. Young out.